Good afternoon, class. Today we're going to talk about the law of sines in the area of an oblique triangle. If you do not have a copy of the printed notes, please feel free to just copy these directly into your composition notebooks. Just make sure they are well labeled. If you do not have a calculator, you do need one. It does not have to be a graphing calculator, but please make sure the mode of your calculator is in degrees. So we are no longer working in radians, we are working in degrees. So if you do not have a calculator, take a moment, hit pause, and go grab one. All right, so we're going to talk about oblique triangles. So we basically spent the entire first semester talking about right triangles. So it's kind of like our underlying theme. We're going to switch away from right triangles and talk about oblique triangles. So what is an oblique triangle? An oblique triangle is any triangle that is not a right triangle. And for all practical purposes, you can technically stop your definition there, but an oblique triangle could be a triangle that is acute, or it could also be a triangle that is obtuse. But the one defining characteristic of all oblique triangles are that they are not going to have any right angles. So in order to solve an oblique triangle, we need to make sure that the following conditions are met. As you look at these reasons on the right, you should recognize most of them as congruence properties from geometry class. Number one, both of those methods require two angles and a side, angle, angle, side, and angle, side, angle, where the side is between your two angles. And we can use the law of sines to solve those types of triangles, which is what we're going to learn today. If you look at reason number two, we actually just talked about this in honors geometry today. Angle, side, side, ASS, no donkeys in geometry. So when we think about angle, side, side, we never really understood why. Your teacher just said, you can't use this, and we moved on. We are finally, 2 years later, going to talk about why we cannot use angle, side, side to prove that two triangles are congruent. The last two methods involve at least two sides and will require the use of the law of cosines, which we will learn about later in this unit. So the law of sine says you have a triangle ABC. So if I think of a triangle ABC and I come over here and draw myself an oblique triangle ABC, the capital letters will represent angles, where the lowercase letters represent sides. So if you take angle A directly across from angle A, you have side A. Directly across from angle B, you have side B. And directly across from angle C, you have side C. Hopefully you did the little activity, whether it was the group activity in class or the Desmos activity, to develop the law of sines. So this should look somewhat familiar. I will go ahead and tell you that some people like to take the reciprocal and write it with the side on top and the sign of the angle on bottom. Just so you have a visual, this is what it looks like. It does not matter as long as you're consistent. So if you put angles on top, then they need to be in the numerator the entire problem. If you put the angles in the denominator, then they need to be in the denominator for the entire problem. A couple things about solving and law of sines and law of cosines. When it asks you to solve the triangle, what does that really mean? Basically, it means you're going to find all the missing parts. So at the end of the problem, you will have all three angle measures and you will have all three side measures. So solve essentially means find all the missing sides and angles. If a picture is not drawn, I suggest you draw it. Some of you will not need that, but some of you, just that extra visual will really help you determine what is going on. When using the law of sines, the side-side angle case, the smaller of the two, actually that should say side angle side case, no, that should say angle side angle, I don't even know what it should say, case, the smaller of the two angles must always be determined first. Why is this? Okay, the reason for this is, if you think back to last semester, I'm not going to refer back to last semester very often, when we take the sine inverse of a function, we can only get answers or output values between -90 and 90 degrees. So you can take the sine inverse of any number between -1 and 1, and your output will be between -90 degrees and 90 degrees. Then if you think about the reality, we don't have any negative angles in our triangles. So in reality, we're looking for values of y that are between 0 and 90. So in the end, when you use sine inverse, it is only going to give you acute angles. So in the end, sine inverse of x only determines acute angles. So this is going to pop up numerous times throughout the course of this unit, so I just kind of want to establish the baseline. So sine inverse only determines acute angles. It will never tell you if an angle is obtuse. All right. So when using decimal values in the calculator, do not ever round to write them on your paper. You just want to keep storing them in the calculator and using the long decimals. So you can either arrow up and pull up those decimal values, or if you have second and you hit your negative sign, oops, I should just say negative, you can pull up second negative in the TI graphing calculators, whether it's a TI 30 or whether it's a TI 83 or 84. The second negative will pull up your previous answer, or you can use the store button. And so those are ways you can pull up a decimal. The other thing is you are going to round or truncate to 3 decimals. So under no circumstance should you do anything else in this class. I don't care about chemistry and physics. In math class right now, we're doing 3 decimals because that is what's required on the AP Calculus test. All right, let's look at example 1. I'm going to do it first without drawing a picture, and I'm going to draw the picture second. I know that's not how I recommend you do it, but I want you to think about whether you're going to use the law of sines and you're going to use the law of cosines. When I look at a problem, I think of this as mama bear and baby bear. If you have big L and little l, you have mama bear and baby bear. So you can literally come in and write your baseline ratio, sine 29 over 22. And anytime you have that condition met, you're going to use the law of sines. If you don't have that condition met, you're going to have to probably use the law of cosines. So this particular problem, I know that angle M, is 112 degrees, but I do not know what little m is. This step right here is required. You're going to do this about 400 million times over the course of the next week. So after today, if you want to just do the next couple steps in your calculator, that's fine. But today I'm going to just write it out for notes so everybody knows what's going on. If I cross multiply, I get 22 sine 112 degrees equals m sine of 29 degrees. Ultimately, I'm solving for m, so I'm going to take the sine of 29 degrees. Cancel, cancel. And now you have a calculator ready problem. So take a minute, type that into your calculator. Do not round. You could actually type that all in the same line, so there should be no rounding. Anytime they give you units in the problem, you need to carry those units throughout the problem. If you need to hit pause, go ahead and hit pause and finish out the problem, but you should get 42.074 centimeters. So now you have big M and little m. So now I got to think about angle N. So if you're not sure about angle N, if you draw your triangle, I'm going to label my obtuse angle M is 112. I just found little m to be 42.074. Angle L was 29 degrees from the problem, and directly across from that you had 22 centimeters for the side length. And now you need this third angle N. So ironically, people just like, this blows their mind, but the 3 angles of a triangle add up to 180. So you can literally just do that in your calculator, 180 minus 112 minus 29. And I'll do the quick math for you on this one. You actually get 39 degrees. So angle N is 39 degrees. And now the only part of my triangle I don't know is little n. So I'm going to come back and I'm going to apply the law of sines again. And this next step is required. If you don't do it, I will not give you full credit on the homework assignment. So again, I'm going back to my sine A over A concept. So I know the sine of 29 degrees over 22. But this time I'm looking at angle N. So angle N is 39 degrees over little n. So at this point, hit pause, go to your calculator. If you need to show your work to get a calculator ready, great. If you're ready to put it in the calculator, go ahead and do that. Hit pause until you have the answer. And for your answer on this one, you should get 28.557 centimeters if you truncate it, or you may get 28.558 centimeters if you round it. All right, beautiful. So now we have solved this triangle. We have all three missing sides and all three angles. Okay, so example number 2, we have a triangle. So this time I have mama bear, I have angle A, and I have baby bear is 22. So I'm going to go ahead and take the sine of 26 over 22. This time I have little b. So I have little b, so since I put the side on the bottom on the left, I'm going to have to put the side on the bottom on the right. So I'm consistent. That's the biggest thing. Sides with sides, angles with angles. In my numerator, since that was little b, this is going to be the sine of big B. This is when you are going to use sine inverse. So you're going to have to use sine inverse when you're finding angles. So same thing, this is a calculator, this is not a calculator ready step, this is a required problem setup. If you do the rest of this in the calculator, I'm fine with that. I'm going to go ahead this time and I'm going to show my work. So 24 sine 26 equals 22 sine of B. Ultimately, I want B by itself, so I'm going to come divide each side by 22. So the sine of B equals 24 sine 26 over 22. And now we know that if we want to get that sine by itself, I'm going to have to come in here and I'm going to take the sine inverse of both sides. You can put this in your calculator multiple ways. Go ahead and hit pause, put it in your calculator, but do not round until the very, very, very end of the problem. So hit pause until you find angle B. All right, welcome back. If you entered your information into your calculator correctly, angle B is 28.569 degrees. If you have anything but that exact answer, you are not correct. You have a rounding error and you need to come see me tomorrow so we can get it resolved. Since I already know what angle A is, so basically since angle A was 26 degrees and I have 2 of my 3 angles, I can add these up and subtract from 180. So hit pause, take a minute, find angle C. So welcome back. Angle C is 125.430 degrees if you truncate it, or it's 125.431 degrees if you round it. So now I have my three angles. I have 2 on my sides, so I'm missing side C. So I tend to always use the same starting point. So here I started with sine 26 over 22. And now I need C, so I have to use angle C. So sine of 125. I'll be honest, I'm a truncator, so my answers will all be based on the truncated answer. So since this angle right here was big angle C in my denominator, I'm going to be looking for little angle C. So at this point, it's a cross multiply and divide problem, so hit pause, and when you have the answer, go ahead and hit resume. If you did your calculator work correctly, you should have 48.892 inches. Make sure that if they give you a unit in the problem statement, that you go ahead and continue using the same unit throughout the problem. Perfect. All right, those are the 2 ways you will see the side angle side case and the angle side case. Did I say that right? The law of sines. So we're going to leave those 2 examples. No, the angle side angle or the angle side case of the law of sines. So I'm going to leave those 2 problems there and I'm going to talk a little bit about area. So we can actually kind of use the law of sines in a sense to find the area of an oblique triangle. So if we think of the height of the triangles, if we come over here to the triangle on the left, I'm going to change colors here, the triangle on the left, if I write an equation using A, B, and H, I can come in here and say that the sine of angle A equals the opposite side over my hypotenuse, B. Same if I'm looking at this picture over here. I have angle A right here, even though I'm using that external right triangle that does represent the height of the triangle, I still get the same equation. Sine A equals the height over my hypotenuse. If I take a minute and solve that for H, I get that B sine A equals the height of my triangle. So now if I think about area of a triangle is 1/2 my base times the height of my triangle. So if I look at this particular picture, my base is C, so I have 1/2 of C. I know my height is B sine A because I pulled it from right here. So this is really my area formula in terms of angle A and my two sides C and B. So the area of an oblique triangle is 1/2 C times B times the sine of angle A, as long as angle A is the included angle. Okay, so if we look at my pictures, what do I mean by included angle? Okay, here's C, here's B, and A is right here. So basically by included angle, we have a side angle side case. All right, how am I going to use that formula? Here's a great example. If I ask you to find the area of a triangular lot containing side lengths, or two sides that measure 84 yards and 55 yards, and they form an angle of 115 degrees. So I'm going to come in here. I have a nice oblique obtuse triangle. So right here, I have my angle of 115 degrees. One of my sides is 84 yards, and one of my sides is 55 yards. So my formula for area of an oblique triangle is 1/2, and it's basically the two sides. So one side is 55, one side is 84. So 1/2 base time, well, 1/2 side 1 times side 2 times the sine of my included angle. So just make sure that this is the included angle. If it's not the included angle, then this formula will not work. Basically, you now have a calculator ready problem, and if you take a moment, plug all your numbers into the calculator, you should get 2093.570. They gave you a unit, and because we turned our unit into area, it's going to represent yards squared. All right, you have an assignment today. It's out of your book, so take some time. You can use your book. I put a link on your Canvas page, or I have sheets that I copied out of the book in class for you to use. So if you have any questions, please feel free to ask me in class tomorrow, and otherwise we can get started on our assignment. Have a great day.